Across the United States, millions of engines fail long before they should. They quietly wear out around 150,000 to 200,000 miles, and the driver never realizes the real cause. It isn't aggressive driving or bad luck. It's chemistry. The wrong oil slowly grinds an engine down from the inside. Camshafts wear. Piston rings stick. Sludge clogs oil passages that were designed to carry only clean lubricant. But some engines tell a completely different story. The secret behind those engines is not maintenance. It's the oil itself. Comment below which engine oil you use in your car. Oil number 8, Castrol Edge. Full synthetic Castrol has been producing engine lubricants for more than a century, and over that time it built a reputation for reliability in both everyday vehicles and high-performance engines. But the real shift came with the development of Castrol Edge and its pressure-activated additive system. Inside every engine, the most dangerous moment occurs under heavy load. Hard acceleration, towing, climbing hills, or sustained highway speeds force metal components to operate under intense pressure. Under these conditions, the protective oil film between moving parts becomes the last barrier preventing direct metal contact. Castrol Edge was engineered specifically for those moments. Its additive system strengthens the oil film when pressure rises, reinforcing the protective layer exactly when engine loads peak. Instead of simply maintaining lubrication, the formula adapts to stress and increases resistance to film breakdown. Independent wear testing has shown that high-stress additives can significantly reduce measurable metal particles in used oil analysis. Fewer iron particles in the oil means less microscopic damage occurring inside the engine over time. Castrol Edge also carries approvals from several demanding European manufacturers whose engines operate at high temperatures and tight tolerances. The result is a lubricant designed not just to meet basic standards, but to protect engines during the exact conditions where most long-term wear actually begins. Oil number 7, Royal Purple HMX High Mileage Synthetic. Most engines begin showing signs of wear long before drivers realize it. Small oil leaks, rising oil consumption, and reduced compression often appear gradually after 75,000 miles. At that point, many oils simply try to maintain lubrication. Royal Purple HMX was designed to address the aging process directly. High-mileage engines suffer from two common problems. First, internal seals harden from years of heat cycles. Second, microscopic wear on metal surfaces increases friction and oil burn. Royal Purple HMX targets both. The oil uses a synthetic base designed for stability under heat and load. More importantly, its additive system creates a thin protective layer that bonds to internal metal surfaces. This film remains in place even when the engine is off, which is important because the most damaging wear often occurs during cold starts before full oil pressure builds. HMX also includes seal conditioning agents. Over time, rubber seals shrink and harden, allowing oil to escape past valve guides and gaskets. By gently restoring flexibility to these seals, the oil can help reduce minor leaks and slow oil consumption in older engines. Instead of treating high-mileage engines as worn-out machines, Royal Purple HMX focuses on stabilizing and protecting components that have already seen years of mechanical stress. For engines approaching 6 figures in mileage, that difference can significantly extend usable life. Oil number 6, Liqui-Moly Moligen New Generation. German automotive engineering is known for tight tolerances, high operating temperatures, and engines designed to perform for hundreds of thousands of miles when properly maintained. Oils developed for those engines must meet extremely demanding standards. Liqui-Moly's Moligen New Generation was created with exactly that environment in mind. The defining characteristic of this formula is the use of molybdenum-based friction modifiers. These microscopic compounds attach themselves to metal surfaces inside the engine and create an ultra-thin protective layer between moving parts. Instead of relying solely on the liquid oil film, this bonded layer helps prevent metal surfaces from touching even under heavy stress. This becomes particularly important in high-load situations such as turbocharged engines, high-speed highway driving, or extended operation in hot climates. In these conditions, oil temperatures rise and mechanical stress increases dramatically. Molybdenum additives reduce friction within the valve train, piston rings, and bearings. Lower friction means less heat, reduced wear, and improved long-term mechanical stability. Liqui-Moly oils are also designed to meet strict European manufacturer approvals, including specifications used by several performance-focused brands known for pushing engines to their limits. The result is a lubricant built not just for basic protection, but for engines engineered to operate at high precision for extremely long service lives. Oil number 5, Valvoline Extended Protection Full Synthetic. Valvoline has one of the longest histories in the lubrication industry, dating back to the earliest days of the automobile. Over more than a century of engine development, one challenge has remained constant: preventing metal components inside the engine from slowly grinding each other down over time. Valvoline Extended Protection was formulated with that exact problem in mind. Modern engines operate under higher temperatures and tighter tolerances than older designs, which means the oil must maintain stability even after thousands of miles of heat cycles and mechanical stress. One of the most important elements in this protection system is the anti-wear additive package. These compounds form a microscopic barrier between critical components such as camshafts, lifters, and piston rings. When pressure increases, the additive layer absorbs the contact forces that would otherwise cause direct metal wear. Another key factor is oxidation resistance. As oil ages, heat and oxygen can break down its chemical structure, forming sludge and deposits that restrict oil flow. Valvoline Extended Protection uses stabilizers designed to slow that process, keeping the lubricant cleaner for longer periods. The goal is simple but critical: maintain a stable protective film throughout the entire service interval so that the engine continues receiving consistent lubrication from the first mile after an oil change to the last. By now you know something most drivers never learn. Engine life isn't luck, it's lubrication and maintenance. If you want more deep dives like this, like the video and subscribe to Car Failure Files. Oil number 4, Mobil 1 Extended Performance Full Synthetic. Few names in the lubrication industry are as widely recognized as Mobil 1. Since its introduction to the consumer market in the 1970s, Mobil 1 has played a major role in bringing synthetic oil technology into everyday vehicles. But the real strength of the extended performance formula lies in how it handles the long-term stress placed on engine oil. Inside a running engine, oil is constantly exposed to extreme temperature swings. It must flow quickly during cold starts while still maintaining a thick protective film when the engine reaches full operating temperature. Achieving both requires a stable viscosity profile that does not break down over time. Many oils rely heavily on viscosity modifiers, polymer additives that help oil behave properly across temperature ranges. The problem is that these polymers can shear down under repeated mechanical stress, leaving the oil thinner than intended after thousands of miles. Mobil 1 Extended Performance reduces reliance on unstable polymers and instead focuses on base oil stability and a balanced additive package. This helps the oil maintain consistent thickness across the full service interval. The result is lubrication that remains dependable even after extended mileage, helping maintain oil pressure, protect bearings, and reduce long-term engine wear during demanding driving conditions. Oil number 3, Pennzoil Ultra Platinum Full Synthetic. Most engine oils begin their life as crude oil pulled from the ground. Pennzoil Ultra Platinum follows a very different path. Instead of starting with crude, it is produced using a process that converts natural gas into a highly refined synthetic base oil. That difference in raw material changes the entire chemistry of the lubricant. Crude oil contains trace impurities that remain even after refining. Over thousands of miles inside an engine, those impurities can contribute to oxidation and deposit formation. Deposits slowly accumulate around piston rings, inside oil passages, and along internal surfaces that were designed to stay clean and free-moving. The gas-to-liquid process used in Pennzoil Ultra Platinum creates a base oil with extremely low impurity levels. Fewer contaminants in the base stock means fewer byproducts forming during combustion and high-temperature operation. Cleaner oil leads directly to cleaner pistons and freer-moving piston rings. When rings move freely, they seal the combustion chamber more effectively. That helps maintain compression, preserve power, and reduce oil consumption over time. Pennzoil Ultra Platinum was designed with a focus on long-term engine cleanliness. By minimizing deposit formation from the very beginning, it helps prevent the internal contamination that often shortens the lifespan of otherwise healthy engines. Oil number 2, Pennzoil Platinum Full Synthetic. Pennzoil Platinum brings much of the same chemistry found in its Ultra Platinum counterpart, but focuses on delivering it in a formula designed for everyday drivers and regular maintenance schedules. The core of this oil still comes from the same gas-to-liquid base oil technology that produces a highly pure synthetic lubricant. Purity in base oil matters because it determines how the oil behaves under heat, pressure, and long service intervals. When oil contains fewer impurities, it resists oxidation more effectively and forms fewer deposits as it ages inside the engine. Deposit formation is one of the silent causes of engine decline. As carbon and sludge accumulate, piston rings begin to stick in their grooves, oil passages gradually narrow, and internal friction increases. None of this happens overnight, which is why many drivers never connect it to the oil they use. Pennzoil Platinum focuses on preventing those deposits before they begin. Its detergent and dispersant additives help suspend contaminants so they remain trapped in the oil filter instead of settling inside the engine. By maintaining internal cleanliness and stable lubrication, the oil helps preserve compression, reduce friction, and maintain efficiency across thousands of miles. For drivers who want strong synthetic protection without moving into specialty or racing oils, Pennzoil Platinum offers a balanced formula designed to support long-term engine health. Oil number 1. Amsoil Signature Series Full Synthetic. Amsoil has long been associated with high-performance lubrication, and the Signature Series represents the most advanced formulation in their consumer lineup. Unlike many synthetic oils that begin as heavily refined crude, Amsoil Signature Series relies on a base stock engineered from uniform synthetic molecules designed for stability under extreme mechanical stress. Uniform molecular structure allows the oil to maintain a consistent film between moving engine components. Inside a running engine, thousands of metal surfaces slide against each other every second. Bearings rotate, camshafts press against lifters, and piston rings travel along cylinder walls at high speed. When the oil film weakens, those surfaces begin to make microscopic contact, slowly wearing the engine down. One of the key measurements used to evaluate oil durability is volatility, which indicates how much of the oil evaporates under high-temperature conditions. Lower volatility means more of the lubricant remains in the engine instead of burning away during operation. Amsoil Signature Series is engineered to resist evaporation and maintain its protective thickness across long service intervals. This stability helps reduce oil consumption, maintain consistent lubrication pressure, and limit deposit formation over time. The result is a lubricant built for extended protection, capable of maintaining a stable protective film even in engines operating under heavy load and demanding driving conditions. Engines that reach 300,000 miles rarely get there by accident. The right oil and the right maintenance make the difference. If this video helped you see engine oil differently, like the video and subscribe to Car Failure Files for more real mechanical insights.